Welcome, everyone. My name is Keith Choi, and I'm the Senior Program Coordinator for the Johns Hopkins Education and Research Center for Occupational Safety and Health. And we're very excited to jointly offer this monthly series of free webinars that focus on the unique challenges facing museum workers. Our partners for these webinars uh, is the George Washington University, and it's my pleasure to introduce Maria Fusco. She is the Chief Conservator and Margaret Wing Dodge Chair in Conservation at the George Washington University Museum and the Textile Museum. Maria?
Yeah, thanks. Thank you, Keith. I'm very glad you guys are joining us in this session today, and very glad that Melody and Ralph are presenting with us. They're kind of, in my opinion, superstars in the community, so we're lucky to learn from them today. And thank you for joining us. I just always try to give a very, very brief background on the series in case people haven't joined before. But the idea was born out of our museum kind of looking at building a safety program relevant to pesticide residues. There are many health and safety separately issues that we encounter in museums. So we just try to put together a series that would allow other people who are kind of building a safer practice to present their work and share ideas and then hear ideas back. So at the end, we'll have a Q&A for any questions anyone has. And, really it's meant to be a dialogue too. So I really am very appreciative of Melody and Ralph joining us today. And then Keith and Chris Spicer at the Hopkins ERC. We've had to partner with industrial hygiene colleagues, epidemiologists, occupational physicians, and really they are key to all of our progress. So this partnership was both functional and has been very effective. So I'm going to turn things over to Melody and Ralph. They'll present, and then we'll finish out with a Q&A.
Thank you, Maria, and thank you for the invitation to participate in this. That was very welcome. So my name is Melodi McAdams. I'm the Senior Tribal Heritage Manager for the United Auburn Indian Community. I'm staff for the tribe. I'm not a tribal member. I've been working for the tribe for about 15 years now doing repatriation work. And as part of that work, it quickly became apparent that potential contamination or treatment with potentially hazardous substances could be a big barrier to repatriation, especially of ethnographically recovered items like basketry and regalia. So as part of sort of setting the framework for future repatriations, I started looking at who in the professional community was doing work surrounding contamination. And I saw that a lot of work had been done in the 90s, but then things had kind of petered out, and that a lot of those professionals were still around, but getting older, and that maybe we were at risk of losing some institutional knowledge. So I went around and talked to people and got a lot of conservators and museum professionals and tribal professionals and industrial hygienists to join an informal contamination working group. And so our working group has been doing a lot of work to make sure that this knowledge about contamination gets preserved and incorporated in a way that makes it easier for museum professionals and tribal professionals to do repatriation in a safe way. Which was very handy, and part of the reason I did it because I found myself in the situation of needing this expert guidance. So Maria, if you don't mind going to the first slide. Thank you. So our presentation is titled Use and Limitations of Pesticide Wipe Sampling, a case study to establish safe use and handling of Nisenan baskets. And I do want to qualify that safe use and handling. We'll detail that a little bit more. I think as I've done work in this area, I've come to realize that safe use and handling isn't maybe is what I want, but not necessarily what I'll get. What I'll get is understanding the risk better. And that's a good way to approach it. Next slide, please, Maria. So what happened, and the reason that we found ourselves in need of doing wipe sampling was because even though we hadn't yet repatriated any baskets from museums and we're kind of slow walking that, we did receive baskets from members of the public. So this is very common probably for a lot of tribal offices, where a member of the public, maybe their grandparent has passed away, or they found something at a garage sale, but they'll find a Native American object and bring it back to the tribe that it came from, which is great. It's kind of an informal repatriation. It's not legally required, but it's people doing the right thing because they know it's the right thing. And so we had some baskets come back to the tribes that way. So because they were just people bringing them back, I didn't have the same information about those baskets that I would have if I'd done the repatriation to a museum. But I didn't have no information either. So I knew that, that these baskets had been passed along in those people's family and that they'd obtained them directly from the weaver. So I knew that they didn't come from a museum setting. And they didn't come from like a professional collector either. They were just a gift from one person to another. So while museums and professional basket collectors did tend to treat things with pesticides, this sort of informal gifting probably is less likely, not impossible, but less likely to have been treated with pesticides. So these baskets that came back, it didn't really have a strong reason to believe they'd been treated with pesticides. And because we were displaying them at the tribal office, we weren't engaging in a risky use. So I was kind of comfortable with where we were at. But then a tribal member came in and they had a basket that they'd purchased at an auction. And the details from the basket indicated that it had come from a museum collection. So museums often did treat basketry with potentially hazardous chemicals. And this individual wanted to use it in their house. So I went from being comfortable with what I knew and had to a red flag over the source of the basket and a red flag over potentially risky use. So at that point, I had reason to believe that I needed to do due diligence and do some testing to make sure that that person wasn't putting themselves and their family at risk. And so obviously, I spoke with that person, and based on the concerns that I identified, they agreed that it would probably be best to do some testing to see if any of the more common hazardous substances were on these baskets. Next slide, please. Thank you. And I think this isn't necessarily uncommon for tribal representatives who are not only receiving baskets back from museums, but from members of the public, and may be working with individuals from within the tribe that have their own basket collections and potential safety hazards there. So I know that we've talked a lot about museum professionals, but in this case, tribal staff may often be that museum professional. And so now as a tribal representative, you're in that position of needing to do due diligence to advise people on risk and to look at testing. And obviously that's always consent-based. So this person didn't have to do the testing, but it was probably a good idea. And you provide that option to them and those resources. So when I approached this, I did immediately go to look for an industrial hygienist. I did that because I'd already had a couple of situations doing repatriation from archaeologically recovered cultural items and tribal ancestors, where the museum had given us data regarding potential contamination. And I didn't know what to do with that. I was like, okay, does that mean that I can't rebury these without creating, introducing hazards into the, groundwater and into the soil. What does that mean? And at the time, no one at the museum side could answer that. Luckily, our outside legal counsel, Courtney and Foyle, had worked with an industrial hygienist in other scenarios. And she introduced us to an industrial hygienist who was able to interpret that data and translate it into, no, these are not levels that you should be concerned about. They're normal levels. And he was able to recommend appropriate PPE and safe handling just in case. So based on those prior experiences, I knew I wanted to use an industrial hygienist. Unfortunately, the industrial hygienist that I'd worked with before was no longer available. So I had to find myself a new industrial hygienist. And I knew from the first time I was looking around that there are a lot of different companies out there with a lot of different levels of expertise and who will charge you a lot of money to do work that may or may not be adequate. So I went and I got 3 different scopes from different industrial hygienists. I already knew Ralph from the working group, and not surprisingly, I did expect this. His proposal was, demonstrated the most technical expertise with the capacity to do what I wanted and was also the most reasonably priced. So we ended up selecting Ralph. Sorry, Ralph, I'm tooting your own horn there, or tooting the horn there. And I felt very comfortable with Ralph because this isn't something that is unimportant. It was very critical that we had confidence in the results of these because of the way that the baskets were going to be used and because of the potential health hazards if serious contaminants were on the baskets. Unfortunately, just picking Ralph did, don't worry, I see the question from the chat. Ralph is going to tell you all about it. So just hang in there on what do industrial hygienists do. So unfortunately, Ralph is not a magic wand and was not going to solve all of my problems for me. I did still need to tell him what I wanted him to test for. And normally I get to be the one to tell museums, you need to figure that out. But again, in this instance, I was basically acting like a museum representative and I needed to figure it out. Next slide, please, Maria. I went to my basic sources. I started off with common knowledge. So there's kind of a common knowledge within California museums and California Native American tribes that baskets, because a lot of the basket collecting occurred in the late 1800s and early 1900s, that a lot of the pesticides that were used then involved heavy metals. Things like mercury, things like lead, things like arsenic, cyanide, that sort of thing. So I kind of started off with what I knew from common knowledge. Then I checked Nancy Odegaard's text, Old Poisons, New Problems. That's kind of the seminal text for contamination in a museum setting. And the new edition should be coming out in the next year or so. So if you don't already have it and you work in this setting, you should have it. So it's a great text if you're trying to figure out, hey, what do I need to test for? And then Marilyn Poole's database, museumpest.net, is another great resource for finding more detailed information. So I checked all of my sources to try and figure out what chemicals did I want Ralph to test for, did I reasonably believe might be there. Next slide, please. And as I said before, unfortunately, I didn't have a lot of information, didn't have those museum records. All I knew was that it came from a museum, the approximate time period, that it was a basket, and that it was most likely a California museum. But that's still a lot of information. I know it's a basket, I know museum setting, and I know the location. So based on that, I was able to say, hey, arsenic, mercury, cyanide, DDT, those were all commonly used. So let's look at those red flags first. So those were what I asked Ralph to test for. Next slide, please. And so one of the things that we also did when we asked for that testing was talked about how the testing should be done. Because if you're familiar with recent updates to repatriation laws and just to working with tribes in general, baskets are very important cultural items, and it's important to be respectful when you're handling them. I think one of the big miscommunications that occurred with a lot of museum representatives and tribal representatives is museum representatives would often silo sacred objects and say, oh, well, we would never do that to a sacred object, but don't worry, this is not a sacred object. And I've had that discussion a lot of times. I've said, sometimes everything is sacred. Sometimes they are all sacred objects. And that just means that you update your protocol and that you're respectful. So we did have a discussion about how we could do the testing in a way that wouldn't harm the baskets and that was respectful. And that was fairly straightforward to work out, but also very important to do. And it was important for that we worked with someone who we trusted, who we believed would listen to us and would follow that protocol, which Ralph did a really good job with. Next slide, please. And with that, I'm going to turn it over to Ralph, who is the industrial hygienist, to introduce himself and to describe the testing. Thank you.
Good afternoon. I'm an industrial hygienist with over 30 years of experience as a certified industrial hygienist. And industrial hygiene is the art and science of recognizing, evaluating, and controlling hazards, typically in the workplace. Museums, it turns out, are workplaces, but they're workplaces and community spaces all in one. So industrial hygienists do get involved in evaluating community-based hazards as well. And I am the past chair of the AIHA, American Industrial Hygiene Association working group on museums and cultural heritage industry. And if you're interested in it, we're always seeking new members. So get a hold of me and you can become a member. We have monthly meetings. Let's go to slide 1. Mr. Choi. There. Like I said, I'm a certified industrial hygienist, but I'm also a certified safety professional and a qualified environmental professional. And again, I'm the past chair of the AIHA Museum and Cultural Heritage Industry Working Group. Next slide. Melody talked about how difficult it is to determine whether objects are contaminated or may have been contaminated, and how you go about selecting which pesticides. As an industrial hygienist, if you tell me which pesticides you're concerned about, I can usually figure out some way of testing the object surfaces. But there are more than 600 pesticides that have been registered for use in the United States. Some of those pesticides were used well before there was any concern about the health effects of pesticides. So the first step is, if possible, look at the past history of pesticide use on your specific objects. Since the data is really spotty, it's rarely sufficient. The history is rarely sufficient for proof of non-contamination, but it might be useful in identifying potential pesticide contaminants for testing. Like Melody said, she used Nancy Odegaard's book and Marilyn Poole's database to help her select the most likely pesticides for testing. Now, there's many techniques for testing. Once you do have an idea of what you're trying to test for, if it's an element like mercury or arsenic or lead, you can use an instrument called an X-ray fluorescence monitor. This X-ray fluorescence instrument is a handheld instrument that shoots ionizing radiation from X-rays at an object, and the elements within that object or on that object then will release fluorescent energy back. And the X-ray fluorescence instrument has a receiver that looks at that fluorescence when you're bathing the object with X-rays. The fluorescence is specific to different types of atoms. And XRF instruments can see about 30 or 40 different elements right now out of the 92 that naturally occur. So this instrument is available, and some tribes have focused exclusively on using XRF to find out if objects are contaminated. But there are problems with XRF, which we'll talk about in a little while. Sometimes you can just measure the air around objects, and if they've been treated with volatile organic compounds, you can collect an air sample and have that analyzed by several different techniques to see if those volatile compounds are present near the object. Remember, though, that they're volatile, which means they evaporate. And if the object's been in existence for a long enough period of time, most of the volatile organic compounds will have already evaporated. But it's a technique that has been and can be used. Another technique is to measure the pesticide residues near the object. For example, if the basket was sitting on a shelf with some shelf paper under it, rather than testing the basket itself, you can destructively test the paper for pesticide residues. Similarly, you can vacuum sample pesticide residues on surfaces near or on the object. This puts typically particulate matter onto a filter that can be analyzed by the lab. And finally, wipe sampling, which we recommended for this set of contaminants. Wipe sampling is an outgrowth of wipe sampling for lead contamination on surfaces in homes. So if anybody's done that type of testing, they're already familiar with this technique. Next slide. Like I said, XRF does a really great job in determining which elements are present in or on the object, but it's inappropriate for organic pesticides because they are not elemental. The instrument itself is fairly expensive, tens of thousands of dollars. So if you have a grant and somebody's funding it, it might not be a bad consideration, but not everybody can afford one. Real-time vapor measurements can only measure airborne volatile organic compounds, so they're really limited for use in surface contamination. Airborne limits, analytical limits, may not be low enough for comparing them to residential use criteria. So it's a technique. It may not be universally applicable. Storage surfaces may no longer be available for direct testing or vacuum sampling. Things get moved around, and paper under an object is seen as disposable and is often disposed of rapidly. So it may not be around for testing. That leaves wipe sampling as really a pretty good method for determining the concentration of pesticide residues on surfaces. However, each wipe sampling does reduce the concentration of residues on the surfaces. So each wipe sampling event reduces the amount of removable pesticide residues on an object. There is also potential for damage. It is a physical process. You are rubbing a wipe against the object. So fragile objects like delicate baskets or feather regalia probably are not good candidates for wipe sampling. Next slide. Like I said, wipe sampling is relatively quick and relatively inexpensive. It's not free. Wipe sampling is adaptable for a wide range of inorganic and organic pesticides, so you can test things that an XRF can't see. The sampling procedures are pretty straightforward, can be taught to museum and repatriation organization members in less than a half hour. And in fact, you can go on the internet and see wipe sampling methods. Like I said, they're widely available for use for lead testing in homes. So it's a modification of that technique. And finally, the one advantage of wipe sampling is you are directly measuring removable pesticide levels. So they're the kind of contaminants that could affect human health in handling of the objects. Next slide. To set out for wipe sampling, you need to set some goals. You need to consider the future uses of the objects. Document the past pesticide use history for each object, if possible. Specify how many objects you're going to need to do wipe sampling and how many pesticides you're going to be interested in finding out the residue concentrations of. After you do that, then you can identify sampling methods and analytical procedures, typically in consultation with an analytical lab. So you need a lab partner. And finally, you need to determine the reporting limits and safe criteria. Next slide. Future uses. Well, if the object is going to be displayed in a heritage center like Melodi indicated some of her baskets were, that display really doesn't involve a lot of human exposure. However, if you're going to put those baskets into daily use in a residential setting for food distribution or for infrequent ceremonies, there is a potential for human exposure at that time. Now, if the object's going to be used for food distribution, we always recommend using a clean barrier layer between the object and the food that minimizes the amount of pesticide that can be distributed to the humans. Ritual or ceremonial use may require additional considerations depending on the duration of contact during ceremonial use and how frequently the ceremonies are performed. However, remember that if you want to display these objects in a heritage center, there's really very limited human contact, so sampling may not be required. Next slide. Documenting the past histories of pesticide use. Past caretakers may have documentation on pesticide use. However, even in well-established museums, it's not usually well documented. Before a lot of pesticides were used, people spread pesticides like mercuric chloride, which is shown here, just to prevent insects and pests from consuming heritage items. Think taxidermy samples, think bird feather collections. And mercuric chloride and arsenic compounds usually do a pretty good job. However, since past histories are not terribly reliable, not terribly well documented, you can use Odegaard's Old Poisons, New Problems to identify the most likely pesticides and get more information on specific pesticides by looking at Marilyn Poole's pesticide database, which has information on about 100 pesticides that have historically been used. Next. Again, it will cost resources to do wipe sampling. So it's nice to know how many objects will be tested, how many pesticides will be tested on each object. And again, we recommend less than 10 for wipe sampling unless you've got a very large surface area, since the surface concentration will be reduced by each wiping event. Where the objects are located is important. You don't want to pay to have an industrial hygienist travel around the country to sample one basket in several locations. So ideally, you'd want to gather all those baskets or all those objects in a single location for testing purposes. And then you want to really consider about what you're going to do for fragile objects. The question is, can objects be handled without damage to the objects? And are the surfaces too rough for wipe sampling? Next. Once you have those considerations, then you can work with analytical labs to identify the most appropriate sampling and analytical methods for the identified pesticides. Labs can often and are happy to provide sampling supplies and sample containers. Labs can advise on the best methods for sample delivery to their lab and any limitations on that. And labs can identify analytical reporting limits for each analyte. It's important to know the reporting limits because if a pesticide is present below those reporting limits, it may not be reliable to use that information for human health protection. The American Industrial Hygiene Association has an accredited lab program. Not all labs do all analyses, so we selected one, ALS in Salt Lake City, that has a concentration for analyzing pesticides. Next slide. Now, here's where the real information comes in. You're going to get a result, but is that analytical reporting limit going to be low enough for comparison to the appropriate safety criteria. There are more than 200 million chemicals that have been named. There are more than 600 pesticides that have been used in the US. There are occupational exposure limits, that's industrial workplace exposure limits, from 500 to 1,000 chemicals, but there's only limited information for most of them as a surface contaminant. So that's where the Canadian Conservation Institute in 2021 released a report by Stantec entitled The Development of Human Health-Based Screening Concentrations for 6 Chemicals Associated with Pesticide Residues on Heritage Objects. Next slide. Fortunately for Melody's situation, arsenic, mercury, DDT have residential exposure screening criteria. Now, cyanides didn't, but you can see that lead, naphthalene, and paradichlorobenzene, another mothball type chemical, do have limits. These are sort of pretty common in pesticides in the museum world. And you can see that for arsenic, in a residential setting, Stantec says, hey, listen, if the concentration is less than 33 nanograms per 100 square centimeters of wiped area, surface area, that they should be able to be used in a residential setting without harming the residences, the occupants, excuse me. If you go down to mercury, that residential exposure criteria is down to 10 nanograms of mercury per 100 square centimeters, which is extremely low concentration. A nanogram is a billionth of a gram. And that's 10 billionths of a gram per 100 square centimeters of 4-inch by 4-inch area. So for mercury, you need to get down to these levels with your analytical method. Now, if your Stantec also had slightly higher use for a special use or a research or a visitor who may handle an object for shorter periods of time. And again, even higher concentrations typically for ceremonial use, where the object can be rubbed against human skin or placed within the breathing zone for longer periods of time than residential use. Next slide. By the way, we don't have those for all. These are the first 6 that I'm aware of. I'm just going to run you through the wipe sampling procedure. Again, this is written up and based on the NIOSH 9100 method. If you search for that on the internet, it's a written procedure. And basically it says, use a template or duct tape to define a wipe area. Well, you wouldn't want to use duct tape on a heritage item because it could leave residues. So we use paper templates. You need to label a rigid sample container like a 50 mil centrifuge tube where you'll place your wipe into for transport to the lab. And you'll need to don clean nitrile gloves for sampling. Next slide. The wipe sampling method uses pre-moistened towelettes that are made of material that will dissolve completely during analysis of lead. So after donning gloves, you open the ghost wipe, which is a wipe that dissolves and meets the ASTM E1792 standards. Spread it out and refold it into quarters. Using moderate pressure, wipe the template area in an overlapping side-to-side, back and forth pattern. After completely wiping the template area, then fold the dirty side of the wipe in to expose a clean side. Next slide. The next wipe with the clean side of the wipe will be in an overlapping top to bottom pattern, basically at 90 degrees to the first pattern. That's the second wipe. The third wipe is after the second wipe, you refold the wipe so you expose another clean side and repeat the side-to-side overlapping pattern. Next slide. Finally, you fold that dirty side of the wipe in and place the wipe into the labeled centrifuge tube and cap the tube. At that point, your sample is in the tube and you need to complete any analytical request forms or chain of custody forms so that you can document where the sample originated and where it goes from that point through analysis. Finally, you package samples for delivery to the lab, and the lab should know how to analyze the samples when they receive them. Next slide. There is a video of the wipe sampling procedure. So if you're interested, you can look at this. Ghost Wipe itself has this video on their website. Okay. And before anybody does wipe sampling, it's worth reviewing this video. Next slide. Next slide. Okay. There are some variations on wipe sampling for different pesticides. For all elements, you can start out with ghost wipes. Most ghost wipes are moistened with distilled water and they don't really interact with the elements. You're getting these solid particles on the ghost wipe to transport in the lab. For cyanide, it turns out you can use ghost wipes as well. The lab advises that cyanide can be sampled for using the same wipe media. For mercury, the lab recommended instead of ghost wipe to use a 47 millimeter glass fiber filter wetted with deionized water. And so that's what we used for Melody's baskets. In terms of DDT sampling, instead of ghost wipe or glass fiber filters, they use, the lab recommends and supplied hexane extracted cotton gauze wipes. That's, they take surgical gauze and spray or dip them in hexane and dry them. Hexane will evaporate. But this hexane extraction will take off some oils that may interfere with the analysis. And then when you go to wipe with these gauze wipes, you have to wet them with a little bit of methanol. That's methyl alcohol. For some tribes, this may not be acceptable. And if you find out that the wipe area, 400 square centimeter wipe area, is not capable of achieving the lower reporting limits, you may have to consider increasing the wipe area because larger area you wipe, the more analyte you get on the wipe, making it allowing the lab to lower their reporting limits. Next slide. When the wipe results are available, typically in 10 working days or so, then you can compare them to those safety criteria. If the wipe result is less than residential use, we still recommend putting some barrier layer between the object and any foods that are served from it. Just in case, right? We're not, in most cases, you're not going to be testing for all possible pesticides. If the wipe result is more than residential criteria use, consider limiting the object to research or ceremonial use, where there's going to be limited human contact. And if it's more than the research or ceremonial use criteria, consider just displaying the object in a sealed case until sometime maybe in the future that the object can be decontaminated. Next slide. Again, prudent precautions say you're going to assume that pesticide contamination is present in the absence of any specific information that you have on past history. You do want to limit human object contact until the object is documented to be pesticide free or have low enough residues to allow limited human contact. And then finally, to display in a sealed case until the object can be decontaminated. Now we're to questions. Hopefully you have some.
Thank you very much, Melody and Ralph. Very, very educational for me both. Thank you so much. And what we're going to do is in the chat, I think we have maybe 1 or 2 questions already. And so we're going to spend the remainder of the time just with a Q&A. Anyone feel free to pose any question in the chat. And I've got a couple questions that even preceded your presentation that people wrote in with that they couldn't join in person and wanted to ask. So let me see what is in the chat real quick. And hopefully, I think both Melody and Ralph answered this, and we had some responses in the chat, but I just wanted to give you both, Melody and Ralph, a chance to verbally share if you want as well. You know, our aim with this program was to make it international, and so people that are not from the US, they were curious as what is an industrial hygienist? What does that certification mean? What do they do? So Melody, you shared a little bit in the chat, and Ralph, you also explained at the beginning of your presentation. Is there anything more you guys would like to share?
Well, there are about 8,000 certified industrial hygienists. So a person who is a certified industrial hygienist has experience as an industrial hygienist, 5 years of experience, plus takes a multi-hour certification exam. It's a multiple choice test, but I tell you, it's one of the most difficult ones I've ever taken, and I like to take tests. That's to become to be viewed as competent in being an industrial hygienist. But of course, the more experience you have, the more different situations you've been exposed to, and the more experience you gain from those past experiences. So, like I said, I've been a certified industrial hygienist for over 30 years.
Melody, anything more to share?
Well, we did start getting a lot of questions in the chat, so I'm happy to share, but I think we should probably get to the questions to make sure everyone's question gets answered.
Yeah. Let's see. I will say too, there are some professionals shy of industrial hygienists that can also be helpful. We
Right.
found in health and safety departments at our university, and then epidemiologists can be helpful, occupational physicians. So the more I learn we need more people on our dream team, so to speak, more people from different backgrounds. And no one person may always have the answer, but you kind of need a composite answer, oftentimes, or composite specialties.
Yeah.
So let's see. Do you have recommendations for sealed containers? Is one question that came in as well. And anyone that's posed a question, feel free to unmute yourself as well if you want to expand more, or if I'm not representing your question fully.
For the sealed containers, because I'm not a museum professional, I don't have recommendations. I would say that Gaylord is a very well-known archival and museum supplies company. And so probably ordering from a company that specializes in those types of supplies and can provide that sort of information. Ralph, I don't know if you have anything to add to that.
My only recommendation would be to make sure that it's a sealed container so that you don't have, or you have minimal ways for contaminants to get out of the object and into contact with humans. So plexiglass boxes or glass boxes, in essence, an aquarium upside down on a surface would be a good container that would have that sealed surface that would prevent contamination from being released. Of course, all those materials, plexiglass degrades over time. So if you're planning to keep it around for the next century, you probably want to use glass.
Thanks to you both. I know at our museum, we sometimes seal things in polyethylene bags that have a Ziploc closure, or we heat seal ends too. So I don't know what your thoughts are on that, Ralph, if that creates more problems or solves some, at least in isolation.
It solves isolation problems, but it's unattractive to view an object.
Yeah.
So, if you want to display the item, it probably needs to have a larger and more clear container.
Yeah, I've been thinking mostly in storage, but yeah, it's not pretty viewing. Another question, you mentioned decontamination methods. So what do you mean by that? And how does one assess whether they're appropriate for museum objects?
Well, that is an issue. Textiles, for example, can be washed with certain detergents and additives that will remove some or most of the pesticide residue. It gets a little bit more difficult with baskets. Baskets can be washed as well, but nobody's done the work to document how well baskets can get pesticides removed from them. You'd have to find a basket with pesticide residues, then give it some treatment, and then retest to see how much residue remains. And that just hasn't happened on a regular basis yet, or hasn't been well publicized if it is.
I think with textile in particular, there's Jay Anderson's doctoral work. And you guys
That's
probably know
exactly
Jay
what
better than I do. Yeah. And he did that with Nancy Odegaard that I found pretty helpful. And
he was looking specifically at arsenic.
Yeah. And on textiles, I think, if I'm remembering right.
Mm-hmm.
But yeah, it's quite an undertaking.
If these are Native American objects, you really want to make sure that you're working with the culturally affiliated tribe to make sure that they're okay with whatever decontamination methods you're trying.
Yeah. And in fact, you may want to try your methods out. I mean, in an ideal world, you take a non-archival basket, maybe even newly woven, treat it with arsenical pesticides, document how much is there, and then see how much you can get off by whatever method you want to test. And then publicize it so the rest of the museum communities can find out what works and what doesn't.
Thank
But
you.
I agree with you. If the tribal recipients of the baskets are not happy with your decontamination method, you really shouldn't use it.
Yeah, I will emphasize a lot of tribal communities have their own protocol for cleaning baskets or other ethnographic objects because everything needs to be clean. And so if you can try to use whatever protocol is appropriate to that culturally affiliated tribe and then see how it's working, that's more likely to be something that's geared specifically toward the objects that that item is made from and to be culturally appropriate. So often like check in, it may be something you weren't planning on doing, but that could work really well.
One final thought, they are using supercritical carbon dioxide for dry cleaning purposes. Now, I'm not sure if baskets would stand up to a dry cleaner tumbling them with supercritical carbon dioxide, but there might be other cultural items that could stand up to that treatment. And carbon dioxide, supercritical carbon dioxide will remove lots of contaminants. And once they're returned to the atmospheric pressure, the carbon dioxide will evaporate. So
would you mind sharing more about the process? Because I've seen it mentioned. It sounds like are they in an enclosed chamber? It's pressurized and CO2 is
right.
introduced?
Yeah, supercritical carbon dioxide is a liquid at high enough pressures. So you're in essence washing garments now in dry cleaning with this liquid, which will remove and absorb contaminants from the clothing. At the end of the process, you return the items to normal pressure, and the carbon dioxide evaporates, leaving, hopefully, no residues on the clothing. Solvents, tetrachloroethylene used to be the primary dry cleaning fluid that was used during my childhood years. And before that, there were other petroleum hydrocarbon solvents that were used, some of which were flammable. Well, tetrachloroethylene is not flammable, so it was preferred for use. But if you've ever smelled dry cleaning clothes, you know that not all of the perchloroethylene evaporates, or it doesn't evaporate immediately. It may take several weeks. But those methods of dry cleaning might be something that could be investigated for museum objects.
I guess an adapted where there's not an agitation process. There's not a
yeah. But again, if you can imagine a sealed container and splashing this liquid on the object, and then separating the liquids from the object itself and returning the object to room pressure, you'd end up with at least superficially cleaner object.
Well, this question brings me to another one that was shared before this session, kind of related. Can Melody and Ralph, can you share any guidance with institutions who are planning to test their collections for pesticides? Here in terms of permission to test mores, how does one approach going about this professionally and ethically? And step one, it sounds like trying to, contact the relevant tribal entities. I imagine with a whole collection that can be pretty tough to do. So are there resources you could point to, guidelines or recommendations? I mean, how would someone tackle something like this?
you're in the United States, it's a legal requirement to check with tribes before doing that testing. The updates to the NAGPRA regulations did make that a legal requirement. I've heard this question from international museums as well, where it may not be a legal requirement, but probably is still at a minimum kind of a moral and ethical requirement. I do know that a lot of museums are getting more serious about contamination, which is good. I like to see that. But the approach that I typically recommend to people is figure out your institutional history, which you do by going to your archives, going to your paperwork, talking to people who worked there a long time ago. Use that as a starting point and kind of do the testing on an as needed basis and as requested basis. I have heard that some museums are doing that blanket testing approach. And honestly, I haven't seen enough of it done to know how well that's going to work out. And I don't know what approach they're using. I know my own experience with this, and I kind of refer to it in our title as we all want things to be safe. But I think what I've been hearing more and more from the professionals I work with is you can test for certain things, but you can't test for everything. It's not reasonable, especially not testing for all contaminants on all objects in your museum. So I do wonder if some of those testing efforts may not be the most well-designed or well-organized, and may just be like, hey, you did a lot of testing, you didn't check with people, and now you kind of need to do testing again. Now that we're at specific objects where we have specific questions. Because every time I'm like, it's safe, right? They're like, it doesn't have X, Y, and Z that you tested for at detectable levels. Not gonna say it's safe. So I would just say, you know, if you have specific objects, especially in a repatriation context, wait until you're working with those tribes. You know, in our own example, I didn't reach out to Ralph for testing until I had a trigger to do so. Until I had a red flag for, hey, I think something may be present, and a red flag for use, and clear consent from the person involved. So I think that it's important to do testing in a critical and targeted way, and not just to mindlessly test. So I do worry about that. That's one of the reasons we formed the working group, and that's part of what we're trying to push here. Go ahead, Ralph.
Well, you know, there are non-contact XRF testing that can be done without touching an item. And some museums and some tribes have found that is where they want to go as a first step. You know, certainly if there's extensive arsenic or mercury contamination of objects, they want to know about it before they receive them. So Harvard, in its museums, according to the Hopi representatives, has been doing XRF testing for about 30 years. So it may be a situation where certainly the recipients get to voice their approval or disapproval, but eventually the museums should do some testing before releasing items to repatriation communities, just to ensure that they're not poisoning people. I mean, there's an ethical responsibility on the museum's part too.
Yeah,
It's a confusing world.
Yeah, that's something we ran up against too, was just, you know, pushing to test because we wanted to be safe. In our instance, it was we were protecting staff. That was what was first driving us. But then recognizing the fact that we'll never be able to test for everything, identify everything. At what point are we satisfied we have enough data? And do we wait those years before we implement anything to protect us? The way you interact with objects in a museum is very different than you'll interact with them in a community. And the way that you view them is very different
I agree.
often. So sometimes what can help is it sounds like you're suggesting that it is a valid thing to delay testing until you have proper information, you have the time to make contacts. Because just making contacts with the appropriate tribes, that can be it takes time, and we found implementing sort of hazard control measures like the hierarchy of controls, like PP&E, engineering, admin controls, things like that, in advance of being able to test everything was a great way to give staff the proper information and proper tools to keep them safe. And you can't really translate that to a community setting, most likely. But that is a way to kind of maybe buy yourself some time as well.
Yes, and area sampling to test the air around objects might be appropriate. And I'm not sure, Melody, if that would require community assent.
I don't speak for all tribes, but in general, yeah, that typically is okay. And often people will also do dust sampling on like the carpet, the walls, because that's getting you to what your occupational exposure is, which is typically what museum staff are concerned about. Because
Right.
ideally, if you're handling the objects, you're already wearing PPE and it's limited.
As well, if someone was trying to say someone's from somewhere in Europe or Asia and is trying the object is from North America and is from a North American tribe, in order to find the correct people to speak with, I guess at least in the U.S. they would look to. I'm educating myself on this too, but if there's a tribal museum associated with the community, a tribal historic preservation office, which people refer to as a TIPO officer, I think. Correct me if I'm wrong in any of this. Sometimes cultural resources departments, it'll be like an admin staff, but those may encompass the museums, the TIPO, and any community curation teams as well. Are those kind of good entities to look to make initial contact?
Well, National NAGPRA on the federal side is a great resource for directing international museums on how to find the appropriate culturally affiliated tribe. With that being said, if you're looking to do this formally, just make sure that you're reaching out to tribes in a formal way. So don't just call up random members of that tribe who are on Facebook or, have a public facing website. Tribes are government entities, just like any other government entity. So you're right, the Tribal Historic Preservation Officer or the other designated person to handle those inquiries for that tribe, which will either typically be listed on the tribe's website, or if you contact National NAGPRA, they have a database of those as well. In the state of California, the California Native American Heritage Commission also can direct people that way. So you do want to make sure that you're contacting the appropriate person if you are making that outreach. Someone who has the ability to give consent on behalf of the tribe.
Thank you for that. Yeah, and for instance, in this presentation, we record it, but we will only share it if we have permission of the Auburn Rancheria community too. So it's always the appropriate thing just to make sure you're getting permission. Don't make any assumptions.
Yeah. And I have spoken to some museums who are just struggling with that and have what they feel is an urgent need to do testing. And I will say everyone's situation is different, and health and safety is very important. I'm not suggesting that anyone neglect their health and safety, but I do think that there are ways to address health and safety while still making sure to get appropriate consent for tribes. So I do encourage people to do both.
We have another question in the chat. How many compounds can you test for with a single wipe? Does each element or compound require a separate wipe? I'm assuming the target compounds can all be sampled with a ghost wipe. Thank you.
And for elements, the elements that can be analyzed for typically with an XRF or equivalent, you can get all of those 20 or 30 elements off of a single wipe. You know, the lab gets the wipe, they put it into solution, digest the wipe, and put all the elements that are present in solution, and they analyze the sample solution for those elements. And they can see 20 or 30, like I said. So full elemental scan can be done in the lab. But the more unusual the compound, the more unlikely it is that you're going to be able to get multiple analytes off of a single wipe. You may have to wipe each one for each pesticide. DDTs, for example, would not be something that you'd be able to find on a normal ghost wipe. And, you know, you need special media for that. So
Ralph,
you have to work with the lab.
Ralph, I'm not sure if you know the answer to this one, but I know one of the things that I have appreciated about wipe sampling versus just XRF sampling at the museum with the XRF machine is that the XRF kind of in the museum tells you presence and absence and you get peaks, but you don't get numbers that can translate to, you know, where you are in terms of risk and safety.
That's correct. Yeah. What an XRF does, like I said, it shoots an X-ray at a surface. The X-ray doesn't stop at the surface. It goes through the material just like a medical X-ray. And so the XRF will see the elements that are present not only on the surface, but within the material itself and perhaps an inch or so beyond it. So you're right, it gives you peaks, but to correlate that peak with a presence on the surface, you need to have a standard or a set of standards. And they have those for lead. I don't know if they have them for other elements.
Yeah, because I know that's the problem I'm running into with a lot of museums right now is they have an XRF machine and they're happy to do XRF testing, which is great for finding things that you didn't know were there maybe, or didn't think were there, but then we still need to do wipe sampling to get to, okay, hey, it's this ppm, you know, over this, you know, area. So in order to get numbers that can translate into, you know, safety standards, the wipe sampling is still needed, at least from what I've done so far.
Yeah, and in fact, Melody, as you know, we were planning to do both to see if we could have some correlation between wipe sampling results and XRF results, and that hasn't yet happened.
Can I ask Ralph, with the ghost wipes you're using, it sounded like they had a solvent on them, most of them.
Well,
A little damp.
deionized
Yeah.
water.
Deionized water. Okay. I know I think the Poison Book Project, if I'm remembering right, they let ghost wipes kind of dry out and then were, you know, touching book bindings, I think, if I'm hoping I'm not presenting that wrong. But did you run against concern about having DI water? I mean, I guess it's not damp. It's not going to wet out the object. Is that what did you guys find with the baskets? Was it wetting them out?
Concerned. I mean, Ralph knew what he was doing, but those of us who didn't, yeah, we were concerned. We were like, oh, it's not going to leave a patch or something. And, you know, so we talked to him about it first. And we also kind of started in, you know, an interior spot on the basket, and it was totally fine.
Yeah, if there were some water soluble dye, for example, that might be affected. And so it's really worth testing in inconspicuous locations, just to be sure.
Mhm. Thank
But
you.
the baskets we were testing achieved their color by using different organic, natural, native fibers. So they weren't dyed.
Would you be worried with a dry wipe method of maybe not capturing an effective sample?
Yeah, actually, the method was developed for use on a clean, smooth surface. And the further you get away from that, the more speculative those results become.
That brings us to another question in the chat. Can you give examples of what surfaces would be too rough for the wipe sampling method? So when are you getting away from that deviation of a smooth surface?
Well, an ideal surface would be something like glass. It's completely smooth. You can define your surface area and wipe it and be sure that you're getting almost all of the contaminant that's present on the glass. The further you get away from that glass smooth surface, like I said, these wipes are relatively fragile. And if, for example, there's a texture on the surface, something like concrete surface would cause the fibers of the wipe to disintegrate, or you may have to use less pressure, or instead of wiping, you actually pat the material so that your wipe material doesn't get destroyed by the surface texture. Some baskets have little ends of the fibers sticking out, and those are terribly difficult on wipes.
Yeah, that was one of the reasons we wanted Ralph doing the testing, because, it does seem like something where someone with experience is going to do a better job. For example, the interior of the baskets did have a rougher texture than the exterior. And I could see, when I was watching Ralph do the testing, that he was kind of making sure to get the crevices sort of in between the basket fibers, but very gently. So it wasn't disturbing the basket, but it was, if anything, probably increasing the surface area that was getting tested, because now you don't just have, you have a 3D thing that you're getting all the dust out of.
It's an art. It's not a
It
science.
is. It is.
At this point. Okay.
Very good. There was, I don't know how much, Melody and Ralph, you can stay on. It's about 2:18 East Coast time, so I don't know if that's 1:18. And are you guys okay for a little bit? Okay. There was a question asked and answered in the chat, a source for the CCI resource that you mentioned, Ralph, which seems like a brilliant resource. And Maeve Moriarty, who's, I know, Maeve, you're in Canada. I can't remember if you were with CCI. You shared a link to it, so please do check that out in the chat. Oh, and then Maeve shared an actual copy of the report, so please do download that PDF from the chat. Thank you both so much for that. And let's see. Another mention, old purchase order records have provided a lot of information, frighteningly. That's true. I was looking through some of our archival information and just seeing annual budgets for the conservation department. And that was a nice, well, not nice, but a effective way to kind of determine what chemicals have been used in the past too. So yeah, a good archival dig will be necessary sometimes. How do you
Yeah, just
perform?
wanted to chime in on that. I'm working with Nancy Odegaard and a few others in our working group, and we're hoping to have a, short 2-page guidance document on how to prepare institutional pesticide use histories, available within the next 6 months to a year, and hopefully posted, consent pending, on a few of the, like NAFPO and National NAGPRA's website, because what I saw when I first started doing this sort of testing work with people who weren't familiar with the problem, is sort of this testing joy where they're like, let's test. And if you don't know what you're testing for or why, then you can't do good testing. And I feel like institutional histories are really critical for figuring out what is most likely to be there. And then your tribal partners are the why, or your museum staff, because those are the risks and the exposure risks. So you really do need to sit down and do your homework with your institutional history before you start doing your testing, or you can spend a lot of money and time on doing the wrong testing. So I do encourage people to check their paperwork, talk to people, figure out what was used. Thank you.
Yeah. What I've done is oral history interviews, looking through old board reports, because depending on the museum, at an early time, it was probably small and the board was in the business of what was going on in say collections care departments, purchase orders, budgets, things like the annual reports sometimes. So there's a wealth of knowledge in those paper-based documents as well. How do you perform non-contact XRF testing? Ralph, you had mentioned that.
Again, that wasn't the subject of our talk, but XRF, you need to look at the characteristics of the XRF. Some of the early XRFs only looked or were optimized for looking at lead. Some of the newer instruments actually can see, like I said, more than 20 different elements. So you get an appropriate instrument, and then it's a matter of following the manufacturer's instructions and pointing the object or placing it against the surface you want tested, pulling the trigger and holding the trigger for the required amount of time, which may be minutes, depending on the analyte you're looking for and the level you're trying to find out. XRFs are fantastic instruments. They're not quite the tricorder of Star Trek, but they're pretty close. And those instruments, in combination with other analytical techniques that are currently available or will be available in the near future, may allow us to see wider ranges of pesticides than we currently can.
Yeah, I have seen that most museums are moving toward the XRF route, because if you're a museum, then probably it's cost effective for you to purchase your own XRF machine and train staff up on how to use it. So I do see a lot of museums purchasing that and using that in-house. It's not wiped sampling though, at least not the way that it's currently being used and implemented. So when you do get, the way that I see museums use it is for presence absence testing with those peaks. And then if you have a peak that's indicating presence, you may need to follow it up with wipe testing to figure out at what levels they are. But I am not an XRF expert, and I've spoken to a lot of other people who use XRF in other industries who seem to feel that probably you can get to levels with that XRF if you use it a bit differently or have a different type of XRF machine. So there's a lot of variability out there.
And the contamination repatriation working group that you chair, Melody, there's a subgroup for XRF users, and they're attempting to, and that's ran by Beth Holford at NMAI, and they're attempting to coalesce a lot of information.
Yeah,
as
and I
well.
think this gets to, what Ralph does, and, a lot of what industrial hygienists do. There are standards and there's protocol, so you can repeat the results and everyone knows what you're doing. I think what happened, I kind of, okay, I'm someone who's on the line who is more familiar with XRF, please jump in. But I think that those standards and protocol are still being built for museum use and interpretation. which means that cross museums and cross people, your people may not be taking data the same way, they may not be interpreting it the same way. So you really, and that's one of the purposes of this sub-working group, is to start setting up those standards. So while XRF is very powerful, there is still a bit of work that needs to be done to make sure that it's consistent.
Thank you. I'm looking at the chat again. Kiefer, thank you. You're correct about TIPO officers. That's good to know. Margaret Geis-Mooney shares a link to one of the first conferences addressing pesticide contamination of California tribal objects in 2000. So there's a link there, contamination of museum materials and the repatriation process for Native California. Let's see, XRF results will be more surface sensitive for the light elements and for the low energy X-ray lines of heavier elements because of the relatively shallow values for infinite thickness in low density matrices. However, for higher energy X-ray lines, arsenic, potassium, mercury, lead, arsenic K, the K peaks, the mercury, I think L values, or lead L peaks, the signals will indeed be able to emerge from greater depths. Their efforts to combine XRF analysis with surface wiping. This is from Aniko Bezur. So please feel free to, take yourself off mute if you'd like. There's a PDF shared as well. And Keith will be sending the files that have been shared in the follow-up emails as well. Aniko shelters them a little more. Surface wipes are folded and placed in a small plastic bag and then analyzed. This looks at the removable heavy elements, in this case lead, but in a surface sensitive way. Thank you for that. And Aniko, if you want to unmute yourself and share more, please do. Another question, do you use the XRF to look for chlorine to identify objects that need further testing for organic pesticides?
I think it's a possibility, but chlorine is relatively common in the biosphere. So I'm not sure if it would really identify chlorinated pesticides, organochlorine pesticides, or not. You're probably going to get some sodium chloride, salt, table salt, that would be present.
Or if something had been wet cleaned, might there be chlorine from the water, if depending on like when they, what kind of water they
chlorine's
were
not in
using?
water, but yeah, gaseous chlorine would evaporate, but chlorine salts would remain. Calcium chloride, sodium chloride, potassium chloride, all of those are fairly common in the atmosphere.
Yeah, I think the chlorine is a tough one because it's not so specific for pesticides. And also it's a very low energy X-ray. And so any kind of non-contact testing would have a really hard time picking it up. And in addition to that, chlorine X-ray lines overlap with lead X-ray lines. So if both of them are present, their determination with X-ray fluorescence is super challenging.
Yeah, that's always the challenge I have is if, is our software identifying lead when I think there's just arsenic, and differentiating that always feels a little tricky as well. If
Yeah,
you have any
the
tips there.
automated, when you run your XRF and with the factory calibration modes, they are checking both the lead L alpha and L beta lines to distinguish from the overlapping arsenic K alpha and L alpha lines. So they are hopefully doing a good job at that. But I think, even if you run your instrument in that kind of auto identification mode, you have to review all the spectral interpretation work.
Yeah, we usually run the auto identifier just to like as a first pass and then remove all the peaks and then look at it ourselves. Very helpful. Well, Aniko, I'm sorry, can you tell me how Did I say your name wrong? I'm sorry if I did.
It's Aniko. Thank you.
Aniko, do you want to
Yeah.
share some more? Thanks for your posts in the chat.
Yeah, we've been looking for this, I think that you bring up a very important question about testing that is looking at removable or transferable materials versus materials that are often on the interiors or not so mobile. And that's why we've been scouring the internet for lead testing methods that are kind of looking in the field of lead testing is, the transfer is really very important. And so the article that I shared, and the person also wrote a master's thesis, which is publicly accessible, is a way to kind of be able to do wipe testing and then screen your wipes with your XRF to see if there are detectable levels. And then they have a decent correlation with the lab gold standard analytical methods for lead. I mean, it hasn't been done for arsenic or mercury, but I think it's an interesting possibility in addition to the vacuum-based sampling, which they're also looking at to do the vacuum and then do field testing of the filters to screen for the presence of lead. And then they've compared those to the wet analytical techniques for those materials. So I think some of those approaches in our field could be investigated, because you're not using XRF directly on the object, but especially with the vacuum, you're not having to wipe, and it could be done in maybe a safer way to not have to apply moisture for those objects that would be sensitive to it. So I think Ralph made some really good points along with Melody about this sort of, what is it that we're testing for? Is it the surface stuff or just sort of bulk things?
Thank you.
Yeah, that's another reason I really like the wipes. For example, we had some glass beads that came back and they tested positive for lead. The museum informed us beforehand, and I was like, well, that was probably in the pigment that was used to make the glass. So XRF, yeah, but I bet a wipe sample probably wouldn't produce lead, because I don't think they're really coming out of that glass. So the difference between XRF sort of testing for what's in the object versus the wipe sample testing for what's coming off the object, and that's sort of the same thing. That's a bit of a critical distinction.
And we have another question here. You may also need a radiation protection program if you're operating an XRF. Usually, but not always, state authorities, state health departments might be able to assist you there. OSHA and state and tribal OSHA plans have requirements too. And the Melody you shared, yes, it's very helpful if you do have an XRF, but it's a big lift to get, especially for tribal offices. This was why for this case study, we went straight to wipes instead of doing XRF. But yes, in order to make sure that you're using the instrument safely and properly, you're not pointing in an unsafe direction, ideally be wearing badges as well that might record. I mean, it's a fairly safe device when used properly, but there's a lot of variables that inform using it properly. We've used our university's health and safety department to get training on that, but not everyone has access to that. So yeah, local and state authorities, federal authorities in your countries might be helpful resources to at least check.
I apologize. I do have to go ahead and step off. I have another meeting that is starting, but thank you so much for the opportunity to participate in this series. It's really good to see more information getting out there and more museums working on this program.
Thank you, Melody. We're grateful to have you and lucky to be able to get you guys to speak.
Have a good one, everyone.
You too. And I do have to go as well, I'm sorry to say. Ralph, thank you too for all your service in the community and for your service today too. and sharing information.
Thank you for having us.